Hello, greetings to you all, and I'm so excited to meet you once again online. Yeah, I welcome all of you back to school. It has not been easy, but I believe that everything is going to be fine. Please, the little advice that I have for you is that you need to stay focused. Right? Stay focused. Whatever you see as your results, don't give up or don't be over happy. Are you okay? Make sure that you stay out from panic and you put in much effort to make sure you get a very good CWA. The starting is quite important, but it's not as important as the finishing. Are you okay? So the game can turn, everything can move about. So be careful. Don't be over happy or don't be over sad. Are you okay? So stay focused and everything is going to be fine. I wish I could turn on my camera so that you see the person behind the video, but it's quite unfortunate. Where I am, camera is not allowed. But we'll definitely meet on campus and we'll say hello to ourselves. You get it? Yes. So we are continuing with our calculus tutorials. Please, if you've not watched the previous videos, try as much as possible to watch them. I'll put the link in the description. So once you start watching this video, I assume that you've already watched our previous videos and you're okay with all what we've done in the past. So this one shouldn't be all that difficult for you. You get it? So we are going to continue with our series, and today what we are going to talk about is the product rule. Right? We're going to talk about the product rule. Then we'll also talk about the quotient rule. Right? The quotient rule. Then we will talk about the chain rule. The chain rule, right? In some books, it's called function of a function. Right? So function of a function. So if you see function of a function, it basically means what the chain rule. Then we will also talk about successive differentiation. So successive differentiation, right? So we'll talk about this one too. And this one is more like differentiating a differentiated function. So I have a function f of x, then I'll differentiate it towards f prime of x, right? Then I'll differentiate again. That's second differentiation, second order differentiation. Then third order differentiation, it can move on and move on and move on and move on and so on. Okay, so successive differentiation means that you are differentiating, let's say, a differentiated function. Okay. We can move on, we have third order, fourth order, fifth order, and so on and so forth. So, but please, in the previous video, right, I always advise you to put this basic differentiation in mind. Let's say I have f of x and its differentiation, dy on dx, or f prime of x, right? So we have some special functions and their differentiation. For instance, if I have axn, right, its differentiation becomes what? Anxn minus 1. Okay. Then if I have, let's say, sine ax, right, it becomes a cos what? Cos ax. Do you get it? Yes. And if I also have cos ax, right, it becomes minus sine what? Sine ax. Do you get it? And if I should have, minus a, it becomes minus a, right, minus a cos ax. Very good. And if I should have, let's say, ax, right, then it's going to be ax. Then the last one that I'll talk about is if I have ln ax, right, it's going to be 1 on x. We talked about this in the previous video, so it's not something new. Please, I'm pleading with you. If you are confused with this type of differentiation, then watch my previous video. Although it might be long, but sacrifice is the most important. Make sure you subscribe to my channel, please. At this point, pause and subscribe. Okay, subscribe to my channel. Yes. So please learn this, and I believe you'll be fine. Okay. Yes. So we are going to talk about the product rule. The product rule. That's the first thing that we are going to do. So with the product rule, right? Assuming I have a function f of x, right, is equal to, how do you call it? The product of two functions, u of x multiplied by what? V of x. In some books, you just see f of x equal to what? U v, right? They don't add the s to it, so it's the same thing. So if I have a function f of x and it's a product of two functions, do you get it? With this one, if I want to find the derivative of this function f of x, then it's simply going to be u of s. I'll maintain the first one and I'll differentiate the v, right, which will be v derivative of what? Of x. Do you get it? Then plus I'll hold the second one, which is v of x. I'm going to hold it. Then I'll differentiate u of s, that is u derivative of x. Then I'll move on. Sometimes there are certain questions that you don't need to show all these things. You need to work it out in your brain and write the answers. That is when we move to the implicit functions, like differentiation of implicit functions. Yeah, we'll talk about that one, but that one is in a different video. But for now, you need to know this formula, right? You need to know this formula. I'm coming to prove it so that at the end you get to understand it very well. You see, my focus here is not for you to just pass your exams, but I want to leave a legacy where someone listening to me can also teach it when he's called upon. Yes. So let's move on. We are going to prove this one. That is, in some books you just see the y on the x equal to what? Equal to, you hold the u and you differentiate the v, right? Then plus you hold the v and you differentiate the u. Yes. So this formula we are going to prove it. So let's say f of x, right, equal to what? U of x multiplied by v of x, right? So from the first principle, we are proving it using what? The first principle. If you've not watched the video, once again, please go and watch it, because we've talked about the first principle in our previous video. So using the first principle, I will say f of x plus h is going to be what? U into bracket x plus h multiplied by what? V into bracket x plus h. Very good. So what is the formula for the first principle? That is differentiation of the function of x equal to what? Limit as h approaches 0, f of x plus h minus what? F of x, right, all divided by h. This is the general formula. Yes. So this is the general formula. So if you should substitute, let's say, equation 1 and equation 2 into the function, then we will say that the limit as h approaches what? H approaches 0. What is fs of h? Is given by what? U into bracket x plus h multiplied by what? V into bracket x plus h minus u of x, v of x, right, all divided by h. You get it? So in order to let it, right, we can introduce the expression u of x plus h multiplied by what? V of x. So the plus, the minus and plus of it, minus and plus of this expression into the equation. Let me call it equation 3. We can introduce the minus and plus of it to the equation. So let's introduce it. So we can say that f derivative of x equal to what? Limit as h approaches what? 0. Then we have u into bracket x plus h v multiplied by what? X plus h, right? Then the minus of it is going to be what? Let me use a different marker. Minus u into bracket x plus h v into bracket x, right? Plus u x plus h v x, right? Then we have our normal expression, which was what? Minus u x v x, all divided by what? By h. So we've done nothing new but just introducing the expression to it. So at this point we can split the numerator into two parts. So we can say that function as the limit h approaches 0 will be what? I'm going to split this one. I'm going to get u into bracket x plus h v into bracket x plus h, right? Minus u x plus h v x, right? All divided by what? By h. So plus u into bracket x plus h v into bracket x minus ux vx, all divided by what? H. So this side has been used as one term and the other one too has been used as one term. It's more like a plus b on what? On c is the same as what? A on c plus b on c. So that's the ideology behind it. You get it? Yes. So at this point, what can we see here? We have u of h here. We also have u of h here. We can factorize it out, right? So let's factorize the u of h and the u of h from that side. So we can see that the derivative as limit of h approaching 0 is going to be u of x plus h, or into bracket what? V into bracket x plus h minus, let me make this a square bracket. Yes, minus v of x, right? All divided by what? H. So I've factorized this u of x plus h out. Okay. Then this side too, all of them are under limits. Take notes. So this side too, we can say that plus, we can factorize v of s out. See that v of x, right? Then what to be left with? To be left with ux plus h minus what? U of x, right? All divided by what? By h. Don't forget, they are all influenced by the limit sign. Okay. So here you see the limit rules. We've learned the limit rules. So what I'm going to do here, you shouldn't be confused. We can find the limits as h approaches what? 0 of only the first term, which is u of x plus h, or into bracket v into bracket x plus h minus v of what? Of x, square bracket close, all on h, plus what? Plus limits as h approaches what? 0, v of x, u of x plus h minus u of x, right? All on what? On h. Do you get it? Yes. So at this point, the limit rules, what is it saying? We can find the limit of just the u of s plus h, right? So this one can be limit as h approaches 0 for the first function, which is u into bracket what? X plus h, times limit as h approaches 0, right? This whole function, that is v x plus h minus v of what? X, all divided by h, right? Yes. Plus limit as h approaches what? 0, v of x, right? Times limit as h approaches 0, what do we have there? U into bracket s plus h minus what? U of x, all divided by what? H. Very good. So here, like the derivative of x, you can see that if I should insert the 0 here, I'm just going to get what? U of x. U of x. And this one represents the derivative of what? Of v of x. This side. It represents the derivative of v of s, which is the same as what? V of x prime. Right. Plus, and this side too gives v of x. V of x. Right. And this also gives the derivative of what? U of x. That gives u x prime. You get it? So that is the proof of the product rule. Are you okay? Yes, that's the proof. So it's very advisable to know it, but nobody is going to ask you to prove it. Are you okay? So I don't think, probably they might ask you to prove it. Don't take this as a yes. Are you okay? Maybe some lecturer can ask you to prove it, and that one is to your own what advantage, or should I say disadvantage? That one is up to you. But please understand how it's being proved, so that at the end, in the near future, if let's say you are given a question, you will not struggle of doing it. Okay, so since we are done proving it, I want us to solve about one question there or two before we move to the next title, the next topic, or let's say the chain rule, or the quotient rule. So let's take an example. So he said find what? The y on the x of y equal to what? This time not the y on the x, but the y on the t. Sorry for using the x. E, right, 3t sine what? Sine 4t. So they can ask you to find this one. Find the y of the s of this. You get it? Take notes. The y over the s is the same as what? Y prime. Any of them, if I use the y on the x, it's the same as y prime. So in some question, they can just ask you to find y prime. So y prime is equal to the y on what? The t. So you should take note of it. In the t or the x, it depends on the independent variable. The x and the t depends on the independent variable, and here the independent variable is what? Is t. So that's the reason why we have the t. So you should take note of it very well. We are going to solve this question. So at this point, we will say, let's solve it. We are given y equal to what? E 3t sine what? Sine 4t. So you can see from this point we have two functions. That's the first one, E3 exponent 3t and sine 4t. So we are going to let u of x be equal to what? Be equal to e exponent 3t, right? So what is going to be the derivative of it? U prime of x. What is it going to be? It's going to be what? 3 E3t. Please, if you are struggling to understand this, watch my previous video. Yes, watch my previous video, because I explained this very well. We are also going to let v of x be equal to what? Be equal to sine what? Sine 4t, right? So what is going to be the derivative of v of x if you are differentiating v of x? It's going to be what? 4 cos 4t. Yes, again, watch my previous video and you understand it very well. So at the end, right, we know the y on the x is equal to what? We are going to hold the u value, then we will differentiate the x function, then plus we hold the s function. We hold it, we don't differentiate it, sorry. We hold it, then we differentiate the u function. Yes, so that is it. these two. So at this point, what is u of x? U of x was given as what? E3t. E exponent what? 3t. Then what's the derivative of the v of s? It's given as what? 4 cos what? 4t. Better. Then plus, what was v of x? V of s is given as what? Sine 4t. Now the derivative of u of s is given as 3 e exponent 3t. Yes. So these are the things that you need. So at this point, let's arrange them very well. We've written them, but let's arrange them very well. Numbers always come first. So 4 e3t cos what? Cos 4t plus we have 3 here, right? So 3 e3t sine what? Sine 4t. So it has been arranged well now. So you can see that we have a common number that we can factorize out, and that is what? E exponent 3t. So then you are going to get e exponent 3t into brackets. What do we have? 4 cos 4t plus 3 sine what? Sine 4t. So that is going to be the final answer. Yes. So that's it. Do you get it? That's it. So that's all that you need to do. Let's solve another question. One question again. Right. So the other question is, find y prime of what? Of you are going to find y prime of what? Of y equal to 3 roots x, then x. So you should take note. Sometimes you don't need to do this in the, how do you call it? You don't need to do this in the workbook that they provide. Right? You need to do it in your brain. That's, you'll be talking about the implicit function, and you see that I'll not be using this one. So you make sure you understand this concept before you move on to my next video. Yeah. If you have any question, you can send it to me. Ask questions from the Telegram page, or you can also personally PM me. Right? I'll respond to you. Yes. So at this point, they're asking us to find this. So solution. How do you solve it? We have y equal to what? 3 roots x ln x, right? So we are going to let u of x be equal to what? 3 roots x, right? So what will be u prime? If you should differentiate u prime, what is it going to be? Take note. See, this 3 root s is the same as 3 x exponent what? Exponent half. So this one will be multiplied with a 3, which is going to give us 3 divided by 2, right? Then x minus what? Minus half. Why are we getting x minus half? Because we subtract the exponent with 1, and 1 minus half minus 1 is the same as negative half. So in all, if you simplify this, you are going to get 3 over what? 2 root x. That will be the derivative. Why? Because the x exponent minus half is the same as what? 1 over what? X exponent half, which is the same as 1 over root what? Root x. So 1 over root x multiplying 3 on 2 is going to give us the 3 over 2 root x. Are you okay? I've really taken my time to break it down into pieces, but when you are solving it, you don't see this. Right? My target is to make sure that I explain to you how we got about all this concept. So I'm trying to break it down to the smallest level for you to get the concept very well. Right? If you don't understand the reason why we had this value, please reverse the video or watch my previous videos and you get the concept very well. Are you okay? So what about how do you call it? The vein. You are also going to let vein be equal to what? Vein of x be equal to ln x. Right. So what is going to be the vein prime of x? The vein prime of x is simply going to be what? 1 on x. Yes. So 1 on x is going to be the final answer for the derivative. Once you are done with this, then we can proceed to say that dy on dx, right, is equal to what? Is equal to, how do you call it? Ux. We hold the u and we differentiate the vein, right? Plus, we differentiate the vein. We hold the vein again and differentiate the u. Okay. So you should take note of it. So let's substitute from this side. What we did here, right? What we did here, we are going to substitute into the expression. So at this point, the u of x is given us what? 3 root x multiplied by the v prime was given us what? 1 on what? On x, plus what about the v of x? The v of x is giving us ln x. Then the u prime is giving us what? 3 on what? 2 root x. Very good. So here we can simplify this expression too. See, this is the same as 3 roots x times x minus 1. This expression here, the first term, is the same as this one. Okay. And this x root s is also the same as 3x half x minus what? 1. Okay, so if I should simplify this one, I'm going to get 3s loss of indices half minus what? 1. And this is going to give me 3x minus what? Half. So at this side, I'm going to get 3x minus what? Half. Are you okay? Then at this point, what do we have? We can maintain this one to see that it's plus what? 3 on 2 times ln x over what? Over root x. Are you okay? Yes. So the first term is giving us 3 over what? Root x. Yes, I told you that x minus half is the same as 1 over what? X half. And is the same as 1 over what? Root x. So that's what we have here. Plus, let's maintain this ln x on what? On root x. Right. So this one can be simplified. We want to get a like term. So we find the equivalent of this. Find the equivalent fraction, right, of this one. We just multiply the first one by what? The numerator and the denominator by 2. Let me write it again and find the equivalent fraction. So to find the equivalent fraction, I just multiply this one by 2 and I multiply this one by 2. Why? Because I want, you see, this is 2 root 2. So I want to have the same denominator so that I'll be able to what? I'll be able to add the numerators. So this one is going to be 3 ln x all divided by what? 2 root x. So you see now the numerators are the same. So I have 6 on 2 root x plus what? Plus 3 ln what? X all divided by what? 2 root x. Okay. So at this point, if I should simplify, I'm going to get 6 plus what? 3 ln x all divided by what? 2 root x. Okay. What can I do again? I can factorize 2 out. Right. So factorizing 2 out, I'm going to get 2 into brackets 2 plus what? Sorry, 3 plus. I can factorize 3 out. Yes, not 2. Pardon me. I can factorize 3 out because 3 is a common factor to 4. 3 into brackets. So this side becomes what? 2. So 3 into bracket 2 plus what? 2 plus, how do you call it? Ln x, right? All divided by what? All divided by 2 roots x. Do you get it? What's going to be the final answer? The final answer is simply going to be what? 3 on 2 multiplied by what? Multiplied by 2 plus ln x, all divided by what? Root 2. So this is going to be the final answer for the derivative. That is dy on dx. Very good. Okay, now let's move on to the next section, which is the quotient rule. Okay, so we are going to talk about the quotient rule now. Okay, with the quotient rule, it clearly states that if, let's say, I have a function f of x, right, inside that is a division of two functions. Let me use u of x. So u of x, or let's say v of x. Yes, u of x on v of x. In some books, you see y equal to v on u on v, right? It's the same thing. There's no difference. Do you get it? Yes. So let's assume that we have a function f of x equal to u of x on v of x, right? Then we will say that the derivative of f of x is given by v of x. You hold the v and you differentiate the u, right? Minus, then you hold the u, then you differentiate the v of x, right? All on v of x squared. Are you okay? So before we solve questions, let's prove it. Let's assume I have f of x equal to the u x on what? On v of x. Are you okay? This one should be equation 1. Then, because we want to use the first principle of differentiation, right? Because we want to use the first principle, we will say that f of x plus h will be equal to what? Will be equal to u of x plus h, all on what? V of x plus h. Do you get it? So in that case, we can clearly state the derivative from first principle. That is, derivative from first principle is given as limit as h approaches what? 0, f of x plus h minus f of x, all on what? All on h. Are you okay? Yes. So in that case, if you should substitute equation 1 and 2 into the derivative, right, then we are going to get limit as h approaches 0, limit as h approaches 0, u x plus h, all on what? V x plus h minus u of x, all on what? V of x. This whole expression divided by what? Divided by h. Very good. We can simplify the numerator. How do we simplify the numerator? We make the denominator the same. Okay, so that we add the numerators. So in that case, what do we do? Limit as h approaches what? 0. I want to find the equivalent fraction of the first term. So I have u x plus h, right? I don't know why I'm interchanging the u and v. I have u x plus h, right? Multiply by v of x. Wait, let me use a different marker. I want to use a different marker so that you see clearly what I'm doing. I'm not changing anything, but I'm just finding the equivalent fraction of it. So v of x, right? All divided by what? All divided by v x plus h multiplied by multiply by the same v of x. So the values are the same, but it's just equivalent. Okay. Then minus u of x on v of x. So to find the equivalent of this one too, I just need to multiply it by what? Vx plus h. So multiply by Vx plus h. Multiply by, I multiply the numerator and the denominator by the same Vx plus h. Do you get it? Yes. So all divided by what? All divided by h. So with this one, I can clearly see that the denominators are the same, right? So I can just add the numerators. So at the end, what do I have? I have limit as h approaches 0, ux plus h, multiply by what? Vx minus ux, multiply by Vx plus h, all on what? On Vx plus h times v of x. Since they are the same, we are just going to write 1. All divided by what? H. Are you okay? So at this point, we can say that limit as h approaches 0, you can bring this denominator down and multiply it with the h. Are you okay? So if we do that, we are going to get limit as h approaches 0, ux plus h, v of x minus ux times v of x plus h, all on what? On v x plus h times vx times what? Times h. Yes, because this is applicable with this rule, assuming I have a over b all divided by c, right? It's the same as a on b times the reciprocal, which is 1 on c, because this one is divided by 1. Okay, so times 1 on c. So if I'm going to get a on what? On bc. So this is the simple rule which was used to bring the vx plus h multiplied by the vx down. Okay, so at this point, what do? We can separate the vx plus h and maintain the other one. So we can have limits as h approaches 0, 1 on what? On vx plus h, multiply by what? By v of x times ux plus h, v of x minus u of x, vx plus h, all on what? On h. Do you get it? Yes. So let's continue. At this point, what can we do? We can use the limit rule, right? To say that we have limit as h approaches 0, we take the first expression, which is 1 on what? On vx plus h, vx, right? It stands alone. Multiply by what? Limit as h approaches 0, ux plus h, v of x minus ux, v of x plus h, all divided by what? All divided by h. Please, if you are confused with why I was able to split them into two, watch my limit video, the video on limits. Are you okay? And you will get the concept. I've done a whole 1-hour video on limits. Limit is not something that is difficult. So I've summarized limits so that at the end you'll be able to understand limit very well. So if you are struggling or you don't know the reason why I was able to split it into two, just visit my limit video and you get it, the concept very well, right? I'll put the link in the description. Okay, so let's move on. At this point, you see I can simplify this side, right? So if I simplify this side, I'm going to get 1 on what? On v x plus 0 times v x, right? multiply by limit as h approaches 0, right? U x plus h v of x minus u x v x plus h, right? All divided by h. You get it? So this side is going to be 1 on v x squared, because this x plus 0 is the same as x. We are going to get 1 v x all squared, right? Then we have at this side we introduce minus u v x plus u v x into the numerator of the expression hierarchy. So if you should introduce it into it, what do we get? You get limits as h approaches 0, right? U x plus h v of x, right? Let me introduce it here. Minus u x v x, right? Plus u x v x. Do you get it? Then after introducing it, what do you have next? Minus u x v x. Do you get it? Yes. Vs plus h. Sorry, I need to write this expression very well. Let me write it very well so that you will not be confused. I think I'm overusing the board. So let me write it very well here. So we have limits as h approaches 0, right? U x plus h and v of x, right? Then I introduce the plus or minus, right? So minus u x v of x, right? Plus u x v of x, right? Yes, very good. I think I have now enough space to write that expression. Minus u x v x plus h, very good. All divided by what? All divided by h. Yes. So at this point, I can split this term into 2, right? So if I should split into 2, I'm going to get 1 on what? Vx all squared times limits as h approaches what? 0. U into bracket x plus h vx minus ux vx all divided by h, right? Plus ux vx, right? Minus ux vx plus h all divided by what? By h. All this one to the square brackets. You get it? So applying the limit rule once again, or before we even apply the limit rule, let's see something. We can factorize the v out here, and this side too we can factorize the ux out. So let's do that. So at this point, I'll have 1 on what? On vx all squared, right? Times the limit as h approaches what? 0. I'm factorizing vx out. So vx multiply by what? Multiply by ux plus h minus, what do we have? We have ux at this side. If I factorize the vx out from this expression, all divided by what? Divided by h. You get it? Yes. So you can factorize the vx out, and we have something like this. Then plus, we can also factorize the ux out from this side. The ux all into bracket what? Vx minus vx minus vx plus h all divided by what? All divided by h. So we put this one into a square bracket again. But do you know that we can see something at this side? We see that this is negative, right? And it is contrary to the first derivative. So it means that we need to negate this expression. So we need to negate this expression. Once we negate this expression, or once we factorize negative out, this side becomes negative and this side becomes positive. So let's work on that one. So we can see that we have 1 on what? On v x all squared, right, times the limit as h approaches 0, right. We have v x all into brackets, what's u x plus h minus u x all divided by h, right. This I want to make it minus because we are factoring negative out. So once we factorize negative out, this side becomes negative. Minus u x, and the Vs of h becomes positive. So let me write it first. Vx plus h, and the Vs also becomes negative. Minus Vx, right, all divided by what? H. Yes, perfect. So at this point you can see clearly that the proof is almost done. So at this point, we see that this side is derivative of what? Of v prime. Or let me even split it so that you see it clearly. So at what do we have here? We have 1 on what? On v x all squared, right, multiplied by limit as h approaches what? 0. We are splitting them. We are using the limit rules. Limit as h approaches 0. V of x, right, multiplied by limit as h approaches 0, u x plus h minus u x all divided by what? By h, right, minus limit as h approaches 0, u of x multiplied by limit as h approaches 0, u of x plus h minus v of x plus h, sorry, v of x plus h minus v of x all divided by what? H. So you see we split it by using the limit rule. So this side will take its limit, this side will also take its limit, this side will take its limit, and the last one will also take its limit. So now at this point we can say that 1 on what? On v x all squared multiplied by what? If you find the limit as it approaches 0 of v of x, you are going to get v of what? Of x, right. If you should find the limit as h approaches 0 of this expression, it's going to be the derivative of u prime, so u prime of x, right, minus taking the limit of u of x is also giving us u of x, and taking the limit of this expression gives v prime of x, right. Yes, very good. So at this point you see that we are done. So the first derivative should be equal to what? This had become the numerator, which is vx u prime of x minus what? Ux v prime of x, right, all divided by what? All divided by vx squared. Yes, so that is the simple proof of the product or the quotient rule. Please take note. I don't know whether your lecturer will ask you to prove or not. Like I said, I have hardly seen them giving such a question that prove that from first the derivative or from first principle prove the quotient rule. I've hardly seen them provide such question or giving such question. But I will encourage you that you understand the concept so that in the near future, if you are called upon to teach, right, you will find it easy and you'll be able to express yourself very well on that day. So at this point, let's focus on solving some questions. We are going to focus on solving some quotient rule questions, and at the end we will break the video is becoming so long, so I don't want a longer video. We will break and we'll continue this in the near future. Are you okay? So let's assume let's say I should find the differentiation of y equal to what? To v 4 sine, right? 4 sine 5x, all divided by what? 5x exponent 4. You get it? So if I should find the differentiation of this question, right? It's a quotient rule. We are going to apply the quotient rule. So at this point, what do? I know that y is equal to what? V sine what? Sine 5x all on what? 5x 4, right? I'm going to let u of x be equal to 4 sine 5x, right? So in that case, what will be u prime? You are going to get 5 times 4 is going to be what? 20. So you are going to get 20 cos 5x. I believe you agree with me. If you are struggling with this, then it means that you've not watched my first video. Please go and watch. And let v of x be equal to what? 5x4. So v of x prime, if you are differentiating v of x, what do we get? We are going to get 20x3. Are you okay? So that will be the differentiation. Again, if you are struggling to differentiate this, watch my first video. Because if you just jump into it at the middle, you will struggle understanding it. So watch my first video and you'll be fine. Okay, so now that we have it, we know the general formula as dy on dx is equal to what? U of x, v of x, sorry, u prime of x, right, minus u of x, v of x prime, all divided by what? V squared, vx squared. Okay. So if you substitute, what do we get? The v of x is giving us 5x4, right? And the u prime, or the derivative of u, is giving us what? It's giving us 20 cos 5x, right? Minus the u of s was giving us 4 sine 5x, right? And the derivative of the v is also 20x cubed, right? All divided by, what of the v? The v was giving us 5x4 all squared. Yes. So now what do we get? We are going to simplify. Let's simplify this very well. So 20 times 5 is going to give us 100. We are going to get 100x4 cos 5x for the first term, minus this side to 20 times 4 gives 80, right? 80x cube sine what? Sine 5x, right? All divided by this side, 5 squared is going to give us 25. 25x exponent 8. If you simplify this, lots of indices, it's going to be 5 squared times x 4 times 2, right? So at the end, what do we get? 25x8. So that's a lot of indices. So at the end, what do we get here? We can, let's split them into 2 before we move on. We have 100x4 cos what? Cos 5x, all divided by what? 25x8 minus 80s cube sine 5x, all divided by what? 25x8. Very good. So 5 goes here 1, 5 goes here 4, right? Then we have 4 goes here 1, 4 goes here, so we left with 4. There's lots of indices. All the s cancel it, left with 4. Then what about this side? At this side, 5 can go into 8 how many times? 5 will go into 8, 5, 1, 5, then remainder 3, 5, 6, 30. So it will be 16. Then 5 can go into this. How many times? 5. This can cancel this one to be left with 5. So at the end, what do we have? We have 4 cos 5x, right? All divided by what? X4 minus 16 sine 5x, all divided by what? 5x5. So this is going to be the final answer for the derivative. Let's solve the last question. I think we are overspending the time. Do you get it? Because I always want to teach for you to understand very well. We are overspending the time. Okay, I'm going to just differentiate the tan of theta. Okay, tan theta. It's good to know it off head, but sometimes to let's differentiate that one. I'm going to use tan theta as the last example. So differentiate. So differentiate, right? Y equal to what? Tan theta. So we are going to differentiate y equal to tan theta. So let's say y equal to what? Tan theta. From the trig rule, we know that tan theta is equal to what? Sin theta on what? Cos theta. Yes, trig rule. So at the end, we can say that y equal to sin theta on what? On cos theta. So let u of x be equal to what? Sin theta. So what to be u prime of x? So what to be u prime of x is going to be what? Cos theta, right? Then we are going to let v of x be equal to what? Cos theta. So what will be v prime of x? That one is going to be what? Minus sin theta. So at this point, if we have these expressions, we can say that the y on the theta, not the s, but this time the theta, the y on the theta is equal to what? V x u prime minus ux v prime of x, all divided by what? Vx squared. So what do we get? So we are going to get the Vx is giving us cos theta. So cos theta, then the u prime is cos theta again, cos theta, right? Minus, what is the Vs? Vs is giving us, no, us, sorry. Us is giving us sin theta. So sin theta, and the Vs prime was negative sin theta, right? So at the end, all divided by what? Cos theta squared. You get it? So here, if you look at this, you can get cos squared theta. Take note. Cos theta squared is the same as cos squared theta. RAK. There's no difference. So cos squared theta, and here we have negative here, we have negative here, so it becomes positive. So plus sin squared theta, right? All divided by what? Cos squared theta. So at this point, from trig rule, we know that cos squared theta plus sin squared theta is equal to 1. That's trig rule. So we can say that 1 over what? Cos squared theta. Do you get it? So at this point, 1 over cos squared theta is the same as sec squared theta. So therefore, dy over dx of tan theta is equal to what? Sec squared theta. Yes. So y over the s tan theta is equal to sec square theta. Sorry, it's theta. I'm really tired. It's theta, yes. So that's it. Please, I'm pleading with you. Watch this video and understand it very well. I've solved 2 questions with you. I'll upload more questions on the Telegram page. Are you okay? I'm going to upload more questions so that you try the product rule and the quotient rule. I'm going to split this video into 2. Tomorrow, I'll upload the, I'll upload the chain rule, right, and the successive differentiation. Successive differentiation. Yes. I'm going to upload the 2 of them tomorrow, God willing. I'm going to tackle that one tomorrow. I'm really tired today, right? So tomorrow I'll upload it, and the video is also becoming longer. So tomorrow I'll upload it, and we will be okay. Please watch this video and understand it very well. I'm going to put more questions over the challenging questions on the Telegram page so that you try. Be sincere to yourself. Be sincere with the environment you are in. And be sincere with everything, right? And I believe that if you do it diligently, right, you are going to pass your exam. Mark it on the wall. You are going to get 80 plus. Personally, I don't like checking people's results. I don't like following up. But I believe that people who watch this video, some of them, or even who diligently, if not some of them, all of them, right, will get A plus. So please, watch this video and be serious with everything that we are doing here. Forget about the beauty and forget about everything, right? Just focus, and I believe that you'll be fine. If you are struggling, you just send me a message or join the Telegram page and ask any question. Experts will be ready to answer you. Okay, so part 2 will be coming very soon. Watch out for part 2 tomorrow. Part 2 of this video tomorrow. I'm really tired and I need to rest more. Okay, so all the best, and I'll see you later on. Bye bye.